There was a page in chapter 5 that said, in the notes, that said from 6.2, remember? Yeah. And it was basically all of these, right? I don't understand why the book never told you these rules until now. That's just not the way we do it. So I told you beforehand, and now this is just everything that we already know how to do, all right? We already know how to take the derivative of sine of u, right? It's negative cosine of u plus c. Okay, so let's just take that for a minute, sine of u, right? When you see that function normally, you see it as y equals sine of x, right? And if you want to take a derivative, it's sine of x dx. And the most embellished version of this that we saw was it had a 2 out front. Okay, big deal. We just take the 2 out, and then you still just have sine of x dx. So sine of x, this is how the default function appears, right? Now, what we're going to do in this lesson is, what if it's not just the default sine of x? What if it's sine of 2x plus 1? What if it's sine of cosine of x? Okay, sine of root x. So with that, what we have to do is the substitution method. All right, so basically all this is the chain rule in reverse. All right, so what we do is this. Remember this notation, we have this function f of x, right? And we said when you take an integral of this, what do you get? You basically get integral of f of x dx, right? Now, when you take an integral, and then when you take a derivative of this, what do you get back?
Same thing.
The same thing. So if we call the integral capital F of x, okay? Now, if I take f prime of x, right? That's the derivative of the integral. That's just f of x, right? So that's that notation again that we're seeing. So if we have this function f of x, then, here we go. These parentheses, they always go away. F of u of x like this, u prime of x. All right, so f of u of x times u prime of x is f of u of x plus c. Okay? Okay. It's just the same thing backwards. So basically, if I take a derivative of this, I get back f of u times u prime, right? So if I have an integral, f of u times u prime, and then, you know, I get this back. Okay, what does it all mean? So many f's, so many u's, you know, whatever. Poor choice of lettering too. But, all right. Because of all these u's, we call this u substitution. Happens to be one of the, okay, so totally one of my favorite things. All right, u substitution, favorite thing. Okay. This is what we call it, u substitution. So now when I tell you u substitution, you know, right? This is at the next math party, u substitution, you know what it is, all right? Okay, u is going to be the inside function, okay? So, for example, if I have sine of x, there is no inside function. It's just sine of x. However, take a look at this example here. I have 2 sine 2x dx. Where is this inside function of which we speak? It's the 2x. So this 2x is the inside function. We call that u. Okay? So we say, all right, I'm going to call u 2x. So u is equal to 2x. That's the first thing you do. Identify the inside function, make it u. Then you have to find du. Du is the derivative of u. Okay? So if u is 2x, what do we do here? We take d dx of u, which is du dx. How much is that? 2. Okay, now we have to write it in terms of du. So we sort of have to solve it for du. So I'm going to take this over to that side, multiply both sides by dx. Only in this case is it okay to do that. Okay? So now what we have is du equals 2 dx. Are we okay so far? Okay.
Just explain one more time exactly what you just did on time.
So I had u equals 2x. Okay? du dx is equal to 2. Just took a derivative. Now, multiply both sides by dx. Don't show me that on your paper though. Okay? Mentally multiply both sides by dx. So now I have du equals 2 dx. No, really. Just the denominator. Okay. Just take dx over this. So du equals 2 dx. Okay? So now what we're going to do is we're going to rearrange and rewrite the integral in terms of u. Okay? Okay, here's the important part. You should no longer have the original variable left. The original variable is x. Once you've done your u substitution, x should disappear entirely. Okay? So, take a look at here. I had 2 sine 2x dx, right? So remember 2x was u, so 2x is going to be u. Now, what's du? It's 2 dx. Is there a 2 dx here? 2 dx. So what I'm going to do, is it okay? Can I bring the 2 over and write it after the sine 2x? Yeah. I could totally do that. So now take a look at what I have. I have sine of u, and 2 dx is just du. So now what I'm left with is sine of u du.
So you just rearranged it?
I just rearranged it in order for me to be able to substitute it perfectly. Okay? Huh?
I think you take that too.
Yeah. Eitan.
Yes. Why did we get rid of how did we get rid of
The
the 2x?
2x, initially, we said 2x is going to be u from now on. So now I substituted u for 2x. So 2x is u.
Okay. Fine. Okay,
Yeah.
Thank you.
So no matter what number is there, like if that 2x was a 5x,
Yeah, we're going to have
still
to
get the same answer. You'd still get sine u.
Yeah, there will be some like recompensating for our coefficients and constants, but you guys will be experts at that very soon.
So does that mean that the answer? No. So what, like, how would you get a different answer than sine u du? Where?
You might get like 3 sine u du or 2 over 3 sine du.
Like the base of
Right,
the
the base,
integral
right,
always be sine u du.
correct. So now that we have integral sine of u du, look at what happens. X disappeared, right? This is what needs to happen. Now you can just take an integral of this. This is just like what we were doing on yesterday's test. Now the integral of sine of u du is just negative cosine of u plus c. Okay? We're good with that, right? That was chapter 5. So this step is chapter 5.
Wait, is that what you do after you
Huh?
step 3? Wait, how did you get from step 3 to step 4?
So step 3, I ended with integral of sine u du. And now that's telling me, hey, integrate sine of u. So I integrate sine of u and I get negative cosine of u. And now the next step is substitute the original variable back in. So here I have a little typo. I ended with negative cosine of u, right? Well, what did we say u was? 2x. So your final answer is negative cosine 2x plus c. Okay? So the u disappears momentarily, and then, the x disappears momentarily, but then the u should go back as well. So here's a rule of thumb when you're dealing with mathematical problems, okay, whether it's math or physics or whatever. When you're solving a problem you are free to introduce into the problem any variable you wish to make life easy for you. Mathematically, you are free. It costs you nothing. The one condition is when you're done solving, okay, you should not have any variables that were not initially given to you in the problem. So when I'm solving this problem, I can put in u's, I can put in v's, I can put in whatever I want. But at the end of the day, when all is final and all is said and done, I only end with the x that I was given to start with, okay? All right, so let's do a couple then. Okay, exciting stuff, people. Okay, so here's what we have. Integral of x minus 7 cubed, right? So what's the inside function here? X minus 7. So we make this our u, okay? So now du is going to be what?
1.
It's going to be 1 times dx, okay? We're going to add a dx because remember, where did it come from? Du dx is equal to 1, and then du is equal to dx, remember? You could just write, like, you could just go here and just say du equals dx. Okay? That you must put in. Okay, so now we need to substitute, and we need to make sure, like, we cover everything. Okay, so x minus 7, that was our u, right? So it's u cubed. And then what do I have left over? Just dx. And what is dx? It's du. Okay, so look at that. It's such a cute little problem to integrate now, right? So I integrate this like I did in chapter 5. U to the 4 over 4 plus c. And now I put in, what was my u? X minus 7 to the 4 over 4 plus c. That's it. Nope, nope. That's it. It's over. Okay?
It's like the first time something was clicking so well.
Chain rule in reverse. Yeah.
So the first step that you do is you figure out what the u is.
Uh-huh.
And the second is you find the derivative of u.
And then you substitute. Like it's like a puzzle. You just have to make everything fit. Yeah.
Will it always give us what you equal?
No, heavens no. It will never give you what u is. But don't worry, I have some tricks.
Well, no, I was wondering.
Yeah.
It was telling us now. So
I'm guiding you,
yeah, no,
and
I
then
was just making-
we take away the crutches. Okay? All right, so take a look here. I have 2e to the 2x. This 2, that's nothing. That could be taken out, brought back in. That's not part of the function. So here I have an exponential function, right? Exponential functions normally look like e to the x. How has this one changed? It's e to the 2x. So what would u equal to in this case? U would equal to 2x. So now du is equal to what? 2dx. 2dx. You always need the dx.
Why not 2dx squared?
Oh, take the derivative of 2x.
Oh, of
Will
u?
we have a
Yeah.
test on this? Will we be given you?
No, never given you. Okay, so now we have to put everything back. So now take a look. I need a 2 and a dx, and that's my du, right? So take a look here. This is e to the u, right? And then look at what I have left over. I have a 2 and a dx. How much is that? That's du, right? 2 dx, look, it's 2 dx. That's du. Isn't that cool? So it's e to the u du. Okay? Okay, so let's do this. You know how I have a 2 dx here?
Yeah.
Okay, I'm going to rearrange this if you don't mind. I'm going to write it as e to the 2x. And then I'm going to bring the 2 and put it afterwards. So it's 2 times dx. I can do that, right? I just swapped the e and the 2. Like here, look, it's 2 times e to the 2x. I just did e to the 2x times 2. Can I do that?
Yeah.
I can totally do that. So now let's start substituting. Okay, I have my integral sign. E I'm okay with. And then what comes after that? 2x. Well, what's 2x? That's a u. And then I have 2dx. But what's 2dx? du. Yeah. Okay. So now what's the integral of e to the u?
EU plus C.
E to the u plus c. But am I done?
No, of course not.
So e to the 2x plus c.
I got it right.
Okay? This rearranging part is optional. If you could see it without rearranging, fine. If you have to rearrange it to minimize careless mistakes, please do that. I'm not going to take points off for anybody because they showed more work, right? I'm not going to think less of you as a student because you went one more step. Yeah.
How did du go?
Huh?
How did du go?
Well, e to the u du, the integral, e to the u. So remember in the last chapter when you have e to the x dx, that whole thing just turns into e to the x when you take an integral. Okay.
No,
Shelly.
Let's do one more together. You can try to not listen to me. Okay. So here we have 2 to the x and then the square root of x squared plus 1. There are so many things happening. Always focus on inside function. 2x is not an inside function. It's on the outside. X squared plus 1 is an inside function. So that's how we pick our u. U is x squared plus 1. So what's du?
2x.
Awesome.
dx is also 2x?
Du is 2x dx.
You just always added dx.
Always.
Didn't you say
Oh.
du is equal to dx?
Huh?
Didn't you say du is equal to dx?
For that problem before.
Wait, so
Okay.
wait, this one.
Yeah.
I feel like the question.
Yeah.
So I did up here, like, I unraveled this, I did the chain rule for this, and that's how I got x squared plus 1. No, that's okay.
Yeah.
So du, though, is taking one more derivative of
Right,
that.
right. Okay, so now look at what we're going to do. I'm going to rearrange this again. And I'm just going to write this first and then put in my leftovers, which is a 2x and a dx. So now this is the integral of the square root of x squared plus 1. But what is x squared plus 1? U. And then 2x dx is just du. So now, back to chapter 5. U to the 1/2 du. I integrate u to the 3/2 times 2/3. Remember, I add 1, divide by the rest. This is chapter 5. We know all this. Plus c. Now I put it back. 2/3. X squared plus 1. 3/2. Plus c. And I'm fine if you leave it in that form or in root form. Yeah.
It's okay to leave it in that form.
Yeah.
Where did the 2/3 u come from?
Okay, so that's chapter 5, right?
Yeah.
In chapter 5, we learned that if you have u to the 1/2, how do you integrate u to the 1/2? You add 1. I did skip a step. U to the 1/2 du. You add 1, so it becomes 3/2. Divide by 3/2. Okay, so I'm going to skip that step from now on because we're older and wiser now. Okay?
Basically, you just multiply by the
There's
reciprocal.
from the get-go, yeah.
I know it's basically over 1.
Okay? All right, so take a look here. Sine of x, e to the cosine of x. So again, students will, look at this and they're, sometimes they're confused. Do I take the sine of x or do I take e to the cosine of x? Always go to the more complicated, to the one that has nested functions. Sine of x is alone. It's sine of x. The other one, it's an e to the sine of x. That's a little bit more nested, right? So we take the cosine of x as our u. Okay? So what's du then?
Negative sine x dx.
Oh my.
Plus c, no?
Well, not yet. Because we're taking a derivative. So it's Negative sine x dx. Okay, so now look at what we're going to do. Let's rearrange this again. Why not? E to the cosine of x. And then I have sine of x dx. Okay, so now there is a negative issue. Okay? Okay, here I have sine of x dx, right? Right here in my integral, I have sine of x dx. Here, can I solve du for just sine of x dx? Can I have it? It'll just be negative du. So what I want is, I want sine of x dx on its own. So that'll be negative du. Just divide both sides by -1. What you really want is to have this leftover stuff in the blue appear exactly as is in your expression for du. Okay? So now we plug it in. It's the fun part now. E to the what? E to the u? Negative du, right? So this is going to be negative du. So I put in the negative before.
You put it on.
You could put it wherever. Just make it
You put it,
like.
outside the integral or no?
Fine, okay. No, we'll put it in there later. There is a packet here. Okay, so this is going to be negative e to the u plus c, negative e to the cosine x plus c. Okay? Yeah.
The first page, it says cosine, no, it says
Yeah.
the green sign, right? Yeah.
Mm-hmm.
So wouldn't it? I don't.
So the first page are the integrals. This we're doing derivatives.
Why didn't we add the c before? Like why did we add it in there?
Because when you're doing this, you're not taking an integral like the first page. You're taking a derivative like chapter 4. Okay? So this is what we did in chapter 4 here, just to clarify. At this step, well, here, at this step is where chapter 5 comes in. Okay? Okay. All right, so the next one I'm going to give you 30 seconds to do on your own. Go! Do it together, because this is fun. I don't want to have you guys do all the fun stuff on your own. Okay. So, okay, so du is, are we okay with this one? Du is 3dx. Okay, so now take a look at here. This is u. So I have u to the 4. What do I have left over?
Dx.
Just dx. So how can I solve my du expression for just dx? Du over 3. So divide by 3, divide by 3. So 1 over 3 du is equal to dx.
Wait, why do you?
Here's why we have to do it. This is our original function. Okay, you know, yay, we picked 3x plus 1 for u. Okay, so if this was my u, now I have u to the 4. What do I have left over? Dx. When you take du equals 3dx, okay, we did, let's start over.
Oh, because you need dx to be
Right.
by itself to match.
So we did du equals 3dx. So now we come back here. Okay, fine, this is my u. What do I have left over? Dx. Whatever is left over, that has to appear exactly as is here. Nothing extra. So what can I do so that here I only have dx and nothing more? Divide by 3, divide by 3. So now I have 1 over 3 du is equal to dx. So when I get back here, u to the 4, 1 over 3 du. Now, huh? So now the 1 over 3 is just a coefficient. Rule number 1 of integrals, you can just take out the coefficients. Yeah. So now we integrate. This is chapter 5 now. 1 over 3 u to the 5 over 5 plus c. So this is, I can multiply these two. 1 over 15 u to the 5 plus c. Okay, so if you want to go back to your algebra days.
5 stands by itself, but you take it off the
Right. Or you could do u to the 5 over 15.
Oh,
Why is it over 5?
Because you do the plus one.
Here we did plus 1. Plus 1. You get 5. And then you have to divide by it. Okay? So now, yeah.
If you didn't take the 1/3 out in front, it would just disappear though.
No, it would still be there. It would still be 1 over 3 times u to the 5 over 5.
Can we try the next one by ourselves?
No,
we're not done.
This is easy. Yeah, we really, no.
We're going to do it together. Okay. So again, most complicated function is this one, and we take the inside of it. Never take square root of 5 plus 2x cubed. Inside function, inside function. So u is 5 plus 2x cubed dx. So now, du is 6x squared dx. We're cool so far? Okay. Since we have extra stuff, let's just rewrite it. Let's just write that square root first. And then what do I have left over? X squared dx. So now I want x squared dx, only x squared dx here. So what do I have to do? Divide by 6. 1 over 6 du equals x squared dx. So now, what do I have? U to the half, good. And then 1/6 du.
Where did u to the 1/2 come from?
Well, it was the square root of u. Here it's the square root of this mess, which you could just do, okay? So now, what am I going to do with this 1 over 6? Move it to the front. And now, what do I do? U to the, well, I'm going to add 1, right? So it's going to be u to the 3 over 2.
2/3.
Right, u to the 3 over 2 times 2/3, I guess. Are they out? Are we okay with this? Yes? We're good with this? Yes.
I understand what's going on. Wait, just
Okay?
don't have your glasses.
So, plus c.
Is it okay if we leave it like that? You don't mind if we don't multiply?
Oh, I do.
Oh.
Of course. So is it 1/9 u?
Okay.
Let's see.
Right, so this is going to be 1 over 9. And what was u? It was 5 plus 2x cubed to the power of 3 over 2
Oh, so now it's all coming back.
plus c. Minus 3 to the power of 4. Okay, so this has an exponent of 4, right? Okay, so what's going to be the u? Okay, these, you're not given u's, so you have to choose them yourself. What is the u here? 2x minus 3. So du equals 2dx. Okay, so now, here, I have 2x minus 3, so that's going to be u to the 4. But what am I going to have left over? A dx. You have u to the power of 4. What's left over? Dx. Just dx is left over. That means this I need to have, right? Yeah, I need to have it appear exactly as it appears in my integral. So 1/2 du will be dx. That's perhaps like one of the most important parts, is you have to recompensate for your variables. Okay. Correct. Correct. Yes. Well, you have to solve it for whatever is left over after you put in the u. Okay, so u to the 4, and dx is half du. Okay, so now what? Right, you have the 1/2, and then u to the 5 over 5 plus c. Good. So what'll happen with the 5 and the 2 underneath? 1 over 10. And what's our u? 2x to the power of 5 now.
I can put that over the 10.
Plus c. Yes.
Oh, that's right, yeah.
So either like this or 2x minus 3 to the power of 5 over 10 plus c. Both are okay. Oh my goodness. Okay, well now we have an ln. Okay. Yes. Now it gets better. So look at what we have here. We have ln cubed of x. Hello. So this is where we have to do a little bit more manipulating, right? What's ln cubed x? Can I write it like this? ln of x cubed? Of course I can. In fact, you should. Okay? So now, what am I going to take as my u? ln of x. Not cubed, just the inside. So u is ln of x, and take a look at... Okay, so something beautiful will happen now. So take a look at what will happen. Okay? What's... I'll just write bigger. What's du?
1 over ln of x. Yeah.
What's the derivative of ln of x? 1 over x.
So 1 over x cubed.
1 over x dx. Okay, so now take a look at what's going to happen here. If you don't mind, I'm going to rewrite that. So I'm going to write ln of x cubed, and then it's over x, right? I'm going to separate it and say times 1 over x instead. Can I do that? I can do that, right? And then I have a dx. So now look, guys, now look.
Now you have what matches.
1 over x dx, 1 over x dx. So this is how ln will work every single time, right? It's beautiful. So now the integral, ln is what? U cubed du. Look at how simple it makes it, right? So now you can do this one. U to the 4 over 4 plus c. And then you plug it in. So it's ln of x to the 4 over 4 plus c. Isn't that cool? So now if you were to take an integral of this, I'm sorry, if you take a derivative, you get that mess back. It's pretty, I mean, this is it, like this is the big deal, okay? Okay, what about here? What do we take as our u? X squared plus 3.
Wait, why did we do that? Like, I don't understand.
Which one?
Because for number b, we did the top, and now we're in the bottom.
For b, we did the...
We did ln it to the x instead of x, but now we're in the bottom.
So we did ln of x for u,
Yeah.
right? And then du, we got 1 over x. So the fact that the derivative of ln is 1 over x, that's what moves us back into the denominator now. You see that? Okay, so go ahead and I'll race you to it with this one. Go.
I found du, but I don't know what it is.
What did we find for du?
I got du and I'm done. Du over 2x equals
Is this what we got?
Yeah.
Okay.
Oh, I got that. No.
So now look.
I didn't even get to you.
Okay. So okay. Let's take a look at what we have now. I have this 1 over the square root of x squared plus 3. Is that right?
Yeah.
And then I have times what?
Yeah.
Not just dx,
Oh,
x dx.
Oh, because you moved the x.
Right. So now, if this is 1 over the square root of u, what do I have left over? X dx.
You divide by 2. so
And
it's 2
then
du.
we have to divide by 2, right? So this is going to be 1 over 2 du. is x dx. So look at how like it's so satisfying because it's like a puzzle and everything just fits perfectly, right? So x dx is what we have, and it's 1 over 2 du. Who would have thought,
You have
right?
to, like, separate everything. You know.
You can, so physically, manually separating things is optional. If you could just see it, it's fine. But, you know, at the end of the day, that's what we're doing mentally, is separating. Okay?
So for the next step, is it 1 over u?
1 over the square root of u. And then what's x dx?
1/2 u.
1/2 du.
So then it's 1/2 times 1 over root a, 1 over root u.
Right, so how else can I write 1 over root u?
1 to the negative 1 over.
U to the
Negative one.
negative 1/2 du. And I can take out the 1/2 because it's just there. Okay, so now what am I going to do? I have the 1/2,
Add 1.
add 1, so I get what?
U to the half.
U to the half times what?
Times,
You don't.
no.
I would have to divide by the half. Yes?
Put it over one.
Times 2.
Put it over 1/2, which is times 2. And look, they go away. So that's just going to be the square root of x squared plus 3 plus c.
How did you get a positive 1/2?
Did you add more?
Ashley,